Hey math fans, welcome back to Chapter 4, Section 5. In this video, I'm going to go over more triangle congruence properties, but these are specifically right triangle congruence properties. So they do look very similar to the previous properties taught in 4.4 and 4.5, but they all specifically deal with right angles, whereas the other ones, the angles weren't really known or they didn't really matter. So the first one to cover is the leg congruence. That basically says if you know that you have two right angle triangles and then two of the legs, the shorter legs, I'm not talking about the hypotenuse here, if two of those legs are known to be congruent, then the triangles themselves are congruent. But speaking of hypotenuse, anytime one of these congruence properties uses the hypotenuse, it will specifically say it, okay? So anytime it says leg, we're talking about one of the shorter legs, just not the hypotenuse, okay? So this one says hypotenuse angle congruency or congruence. The hypotenuse is marked as congruent, and then one of the other angles is known to be congruent. Doesn't matter if it's this angle or that angle, just as long as it's the same corresponding angle in the other triangle. Okay, so the next two would be leg angle congruence, and that has a congruent leg in between two known congruent angles. And then hypotenuse leg congruence is just like the leg one, except one of the legs is the hypotenuse. Okay, so if you know the hypotenuse is congruent, you got to make sure you're using either the hypotenuse leg congruence or the hypotenuse angle congruence. And that's pretty much it to these. So I've got two proofs here that'll highlight two of these properties. Okay, so it's the same image, but I'm just going to use that same image to kind of prove each property. So example 1a says, given that AB is perpendicular to BC and DC is perpendicular to BC and AC is congruent to BD, prove that AB is congruent to DC. Okay, so there's a lot to take in on that, and there's a lot given. So what I've done to structure these notes is I've just given you every other box. But yeah, always start with what's given, because I know proofs are hard. So start with what's given and then try and build towards a conclusion. Like, oh, I'm going to try and prove this with the hypotenuse leg congruency or the leg congruency, you know, something like that. So then if you kind of know what you're going to use, then work towards that. Like, find a statement that will prove that the hypotenuses are congruent, or, you know, find a statement that can prove that some corresponding angles are congruent. So, and then if you're really stuck and there's stuff written out, well, then look ahead and then try and work backwards from that. So it's like there's a lot given. How do I know which is the correct first given statement, you know, based off of what's written here? Well, this says angle ABC and angle DCB are 90 degrees. So it has to be something talking about 90 degrees or leading me to conclude that they're going to be 90 degrees in the previous statement. And that's this right here, okay? If you have perpendicular lines, you're going to have right angles. Okay, so that's what I wrote down for my first statement, the two statements about the perpendicular lines. And because those lines are perpendicular, it's going to form two right angles because it's telling me two pairs of perpendicular lines. So you just say you know that in your reasons or proof side, because that's the definition of perpendicular lines. They all intersect at 90 degrees. So it's saying AB is perpendicular with BC, so that's going to make a right angle here. And then DC is perpendicular with BC, so that'll make another right angle there. And you know, it kind of goes with the picture, but you can never really assume these things unless you're given information that can lead you to conclude that, or unless it's like explicitly given to you. So now that we know that we have two right angle triangles, let's go back to what's given. And so if you just kind of like scratch that out, the next thing that's given is that AC is congruent to BD. So that's what I wrote next in the two-column proof. AC is congruent to BD. That's given. And so if we look at our picture here, AC is this long leg, the hypotenuse, and BD is the other hypotenuse. So these are congruent to each other. So if we're looking back at these right triangle congruency theorems, we're either going to use hypotenuse angle congruency or hypotenuse leg congruency. It's just, you got to work with what's given to you and then what's easiest to prove. Is it going to be easier to prove that another angle is congruent, or is it going to be easier to prove that another side is congruent? So go back and look at your picture, because we've gone through everything that's given to us. We were given the stuff about perpendicular lines, and then we were given this, that these two were equal to each other or congruent to each other. So nothing else is given. So the easiest thing to prove next is that the line where they overlap is congruent to itself. BC is shared by both triangles, right? Because you have a triangle going here, and then you have another triangle going there, and they're both the same line on the bottom. So I can say that BC is congruent to itself, or BC is congruent to BC. And remember, anytime something is congruent to itself, that's the reflexive property. And so, if you notice, we've just proven that one of the sides that's not the hypotenuse and the hypotenuse is congruent along with the right angle. So we've just proven that these two triangles are congruent, and we can say that is so because of the hypotenuse leg congruency theorem. So I put that right there, and I left this spot blank. What do you know is congruent? I know that the triangle of ABC, and remember, you got to keep the same order, the corresponding parts, so is congruent to triangle DCB. Okay, so I know these two triangles are congruent because of the hypotenuse leg congruency theorem, and so the last thing you write in your statement is what you're trying to prove, and we're ultimately trying to prove that AB is congruent to DC. And so, pretty much always, well, I don't know about always, but very often, if you're asked a follow-up question that comes right after you proved that two triangles are congruent, then it's nearly always going to be, just in my experience at least, it's nearly always going to be CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. We know that these two triangles are congruent now. These are corresponding parts of those congruent triangles. So yeah, it'll be corresponding parts of congruent triangles are congruent. Okay, so now I have a similar proof, but I'll use a different property. I'm going to use the HA congruence, the hypotenuse angle congruence. And you'll notice I gave you a little bit different information as well. So same figure, but different given information. So it says, given that angle A is congruent to angle D, and AB and DC are perpendicular to BC, and E is the midpoint of AC and BD, prove that AB is congruent to DC. So you see how I'm not asking about the triangles themselves. I'm asking a follow-up question. These are corresponding parts of these triangles. So if you want, you can kind of already pencil in that the last reason is going to be CPCTC. Again, that's kind of my experience of how these kind of two-column proofs go. I can't say it'll always be that way, but it is often that way. Yeah, the first thing I wrote down was that angle A is congruent to angle D, and that's given. It's clearly given right there. So what I like to do is I like to mark these as I work through them. Angle A is congruent to angle D, and if you can't really tell, redraw your triangle. Basically, they look like this. So, here's ABC, and then here's DCB. So they're like kind of mirroring each other. But yeah, angle A is congruent to angle D. And what comes next? There's another given statement. So if you're not sure, look, there's a given statement here and a given statement there. So it does kind of matter which given statement you write at this point. So look at the line that comes next. It says angle ABC and DCB are 90-degree angles. Does that have something to do with this given statement, that they're perpendicular lines, or does that have something to do with the fact that E is the midpoint of AC and BD? Midpoint doesn't tell you anything about angle measures. Perpendicular lines does, or do. perpendicular lines by definition make 90-degree angles. So this is the given statement that I'm going to write down next. Okay, and so that feeds directly into this. Knowing that these are perpendicular, that'll make 90-degree angles at ABC and DCB, and that is the definition of perpendicular lines. That is, exactly the same as the previous one. So I'll go here, and then I'll mark that they are right angles here and here. And so right now we know that two angles are congruent to each other. And then, so if you have two angles that are congruent to each other, it's either going to be your hypotenuse angle congruency or your leg angle congruency. And then we've already looked ahead and we know it's going to be hypotenuse angle, but I'm just kind of letting you know that the next thing you got to try and prove is that one of the legs is congruent to a corresponding leg. So it's either going to be a leg or a hypotenuse leg. So let's see here. With the given fact that E is the midpoint of AC and BD, that creates, all these line segments here. So these two are congruent because they're cut in half. These two are congruent because they're cut in half. So if it's the midpoint of both these lines, then you can safely conclude that the lines of AC and BD are congruent to one another because of the midpoint theorem. So where am I in my two-column proof here? Well, I wrote down the given statement of E is the midpoint of AC and BD. And then now we know that AC is congruent to BD because of the midpoint theorem. And so because of that, we now know that the hypotenuses of our triangles, because we proved these sides are congruent to one another, we now know that they are congruent. So we use the hypotenuse and two angles. So that means, and one of those angles is a right angle, that means we're using the hypotenuse angle congruence. And so we've proved that triangle ABC is congruent to triangle DCB. And because of that, the last thing that it says, prove that AB is congruent to DC, that is a corresponding part, or those are corresponding parts of congruent triangles. So we know those are congruent because of CPCTC. So this second example I have, this will just kind of wrap it up. I just have three examples. We're going to say, are they HA, HL, LL, or LA, or it could be neither of those. So looking at this first one, you have a side marked. It does appear to be a corresponding side. It looks like this one, they just stood it up. It's like play Tetris in your head kind of thing. Is this a corresponding side? Yes, it does appear to be. And it's in between an angle and a right angle. So yes, this is going to be the LA because this is not using the hypotenuse. All right, so let's move on to example 2. Here I have 3 congruent angles. So if you notice, none of the other, of the 4 congruence properties covered in this section, they all had at least one side marked as congruent. So none of them were all angles, if all angles are congruent. So if you want to think of it like this, the answer is no, you can't tell that they're congruent. If I have a triangle like, I could have a very tiny right angle triangle. Like this triangle could be very tiny. And then you could scale it up and stretch it out, like you stretch out a picture or something. And as long as you do it evenly or proportionately, you'll still maintain those same angles, but you'll have clearly different sizes of triangles. So they will not be congruent to one another. So you definitely need to know, if you know all 3 angles are congruent, that's great, but you definitely need to know that at least one of the sides is congruent. And then this last one, I have one marked side and then a right angle, but you'll notice they are sharing a side. So it's either going to be LL for leg-leg congruency or HL for hypotenuse-leg congruency. And so is this the hypotenuse? Yes, it is. You know it's hypotenuse because it's always opposite of the right angle. So you know something's opposite of it if like the right angle can point to it. So this right angle is pointing to the hypotenuse. So yes, I'll say yes, these can be considered congruent because of HL, the hypotenuse leg congruency. So that's going to wrap it up for these notes. Thank you for watching. Hit that like and subscribe button if you want, and goodbye.